Welcome, dear listener, to the Sleepy Scientist topic, where we journey through the quiet corridors of time and the vast expanses of the cosmos. Tonight, we turn our gaze not to a distant past on Earth, but to the very beginning of everything, or perhaps what lies beyond the Big Bang and time, as we intimately understand them, begin to lose all meaning. Picture a realm where all the cosmic dust, all the gas clouds, all the countless stars and sprawling galaxies, all the planets in our current expanding universe. Time flows inexorably forward, marking the passage of moments, the cycles of seasons, the evolution of life. But within the singularity, time itself would have been compressed, perhaps even indistinguishable from space. The very notion of before or after a specific event would dissolve into an eternal, undifferentiated present. There would be no notion of personal space, no individual consciousness, no quiet corners for reflection or contemplation. Every part of you, every atom that now constitutes your being, would be utterly indistinguishable from every other atom caught in this singular, explosive compression. The very concept of an individual self, a distinct identity, would simply not hold meaning. Emerging into the grand cosmic whole without any capacity for individual perception or experience. There would be no rhythmic ticking of a cosmic clock, no slow progression of light across vast distances. While immense energy would be present, light requires space to propagate, to travel as waves and create distinct forms and shadows. In such a compressed state, photons would be unable to travel freely. It would be a blinding, all-encompassing energy, a pervasive glow, yet without the ability to perceive distinct shapes, colors, or the familiar patterns of illumination and darkness. It would be a uniform, overwhelming brilliance, but one that offers no visual information, only the sensation of pure, undifferentiated energy. Every instant would be fused with every other instant in an all-encompassing, timeless embrace. The conditions are far too extreme for even the simplest of molecules to form, let alone the intricate biological structures required for cells or the complex organization of living organisms. It is a state of raw potential, of pure, unbridled energy waiting for the cosmic clock to begin its tick, for space to expand, for matter to cool, and for the fundamental forces to differentiate and allow, for the emergence of complexity. This initial condition is a testament to the universe's capacity for fundamental simplicity, a stark contrast to the intricate complexity it would later foster. This absence of linear time, this lack of temporal progression, is a profound and where even the most advanced mathematics struggles to fully capture its essence. It is a truly profound and humbling beginning to our cosmic story, a point of ultimate compression that eventually gave way to the sprawling grandeur we observe today. The silent implications of such a beginning are deep inviting a quiet contemplation of what truly defines existence at its most fundamental level. An almost unsettling aspect of the singularity, contributing to its uniquely sucked to be there quality for any conceptual observer, including our own tranquil earth, and indeed all the intricate living beings were once contained. Every atom, every subatomic particle, every fundamental force that now orchestrates the cosmos would have been packed into a volume so minuscule it defies human imagination. Picture heat beyond any earthly flame, far hotter than the blazing core of any star we observe today, hotter than the most energetic supernova explosion. Every interaction, every fleeting moment within this primordial state would be characterized by an energy so immense that the fundamental forces we now recognize, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, might have been unified into a single primordial superforce. There would be no cool recesses, no comforting shadows, no gentle breezes, no respite from this all-encompassing, scorching heat. It would be a relentless, inescapable inferno of pure energy, without the capacity for differentiation or escape. This isn't just an extreme level of crowdedness. The concept of distinct particles, of separate entities, of individual electrons or quarks would simply not apply. Instead, all matter would exist as an undifferentiated, homogeneous plasma, where individual identities are lost in the overwhelming unity of compression. Imagine the sensation of being utterly merged without boundary or form with everything else that exists. This is the conceptual landscape of the Big Bang singularity, the theoretical point from which our expansive universe is believed to have blossomed. It is not merely small. It is, in mathematical terms, infinitesimally so, a point of infinite density and infinite temperature. We'll gently explore the profound questions of cosmic origins, venturing into the realms of theoretical physics and the very edges of human comprehension. So, allow your mind to expand, your thoughts to quiet, and drift into the serene contemplation of the universe's ultimate beginnings. Imagine, if you can, a state of existence so utterly alien, so profoundly compressed, that the very concept of space, to truly grasp the peculiar and almost unnerving nature of this pre-universe state, one must endeavor to set aside all familiar notions of reality. There would be no discernible up or down, no comforting sense of direction, no left or right in any meaningful spatial dimension. All paths, all vectors, all potential movements would effectively converge upon a single, undifferentiated point. The very fabric of space, this grand, three-dimensional stage upon which our universe now plays out, would have been contorted, folded, and compressed beyond any visual or intuitive comprehension. It is a spatial configuration that defies our everyday experience. A universe that, in its nascent form, was utterly devoid of navigable distances. Consider, too, the concept of time. The density of this singular point, as theoretical models suggest, would have been infinite. Hand in hand with infinite density comes infinite temperature. To exist, even hypothetically, in such a state would be to be an inseparable part of a single, unified, vibrating, and infinitely dense entity. Within this extreme environment, the very notion of light, as we understand it, would be fundamentally altered. Life, as we know it, would be utterly impossible within the singularity. This is a theoretical landscape where the familiar rules of existence simply do not apply, where our intuition fails, and where even the most advanced mathematics struggles to fully capture its essence. It is a truly profound and humbling beginning to our cosmic story. A point of ultimate compression that eventually gave way to the sprawling grandeur we observe today. The silent implications of such a beginning are deep, inviting a quiet contemplation of what truly defines existence at its most fundamental level. As our thoughts gently recede from the mind-bending concept of the cosmic singularity, let us now turn our quiet attention to a remarkable individual whose profound intellect and contemplative spirit allowed him to first glimpse the universe's dynamic origins. Georges Lemaitre. Albert Einstein's groundbreaking theory of general relativity, while revolutionary in its description of gravity, was initially modified by Einstein himself to fit this static model. He introduced a cosmological constant into his equations, an arbitrary force designed to prevent the universe from either expanding or contracting. It was a concession to the popular scientific belief, a subtle adjustment to an otherwise elegant theory. Even Einstein, upon first encountering Lemaitre's ideas, reportedly dismissed them, clinging to his static universe model and famously telling Lemaitre, "Your calculations are correct, but your physics is abominable." Such was the entrenched nature of the static universe paradigm. He was a Belgian priest and physicist, a man whose faith and scientific rigor were not at odds, but rather seemed to inform and enrich one another. His foresight, born from a deep understanding of physics and a profound curiosity about creation, guided humanity towards a dynamic, evolving understanding of the universe's vast and ancient origins. He was truly the priest who fathered the Big Bang, a quiet revolutionary in the grand story of cosmic discovery, but of a universe that must have originated from a much smaller, hotter, and denser state. He called this original state the primeval atom, or the cosmic egg. He never sought personal glory, focusing instead on the scientific truth. It was a complex interplay of scientific exchange and, at times, oversight that led to his initial work not receiving immediate, widespread recognition. However, as the evidence mounted, his foundational contribution became undeniable. Einstein himself, confronted with Hubble's observations, later recanted his earlier dismissal, reportedly calling the introduction of his cosmological constant the biggest blunder of my life. Imagine a universe that, in its infancy, was so compact and energetic that it burst forth from a single point, then continued to expand and cool, leading to the formation of stars, galaxies, and all the structures we observe today. This concept, initially a theoretical inference, laid the fundamental groundwork for what we now commonly refer to as the Big Bang Theory. His journey into the cosmos was one of patient observation, mathematical insight, and a quiet, persistent challenge to the prevailing scientific dogma of his time. Hubble, working independently, gathered compelling evidence that distant galaxies were indeed moving away from us, and that the farther away they were, the faster they receded. This empirical data provided observational support for Lemaitre's theoretical prediction of an expanding universe. It was a moment when abstract mathematics met concrete observation, forever changing our understanding of the cosmos. In the early 20th century, the dominant scientific view of the universe was that it was largely static and eternal. Lemaitre, however, approached the universe with a fresh perspective. Having studied engineering, then physics and mathematics, and later becoming an ordained priest, his mind was uniquely equipped to bridge seemingly disparate fields. He studied at Cambridge under the renowned astronomer Arthur Eddington, and later at MIT, where he was exposed to the latest astronomical observations. These observations, particularly those hinting at the redshift of distant galaxies, the phenomenon where light from faraway galaxies appears stretched towards the red end of the spectrum, began to plant a revolutionary seed in his mind. In 1927, 2 years before Edwin Hubble would publish his famous observations, Lemaitre quietly published a paper in an obscure Belgian journal. In this paper, using Einstein's own equations of general relativity, he theoretically demonstrated that the universe was not static at all. It was, in fact, expanding. He even provided an initial estimate for the rate of this expansion, a value now known as the Hubble constant, though it was later refined. This was a profound conceptual leap, moving beyond the prevailing static model to suggest a universe in motion. His paper, written in French and published locally, initially went largely unnoticed by the broader scientific community. Yet, Lemaitre persevered with a quiet conviction. The validation of Lemaitre's work began to emerge with Edwin Hubble's meticulous astronomical observations in the late 1920s. Despite the growing evidence, Lemaitre remained a humble figure. Georges Lemaitre story is a gentle reminder that some of the most profound scientific insights can emerge from a place of quiet contemplation and intellectual persistence. Even when challenging established norms. His foresight, born from a deep understanding of physics and a profound curiosity about creation, guided humanity towards a dynamic, evolving understanding of the universe's vast and ancient origins. He was truly the priest who fathered the Big Bang, a quiet revolutionary in the grand story of cosmic discovery. Having quietly absorbed the concept of our universe's singular, explosive beginning, as theorized by Georges Lemaitre, let us now allow our minds to gently float towards a concept even more expansive one, the multiverse hypothesis. If our universe is just one of many, then perhaps in another universe the laws of physics are subtly different, leading to vastly divergent realities, or perhaps even completely impossible ones. This captivating idea suggests that our universe, vast and seemingly all-encompassing as it is, might be just one bubble, one island, within an infinite cosmic ocean of other universes. Imagine the early universe not as a single, isolated expansion, but as a continuously bubbling, frothing sea. This concept emerges from string theory, a theoretical framework that posits that the fundamental particles of the universe are not point-like, but rather tiny, vibrating strings. Quantum mechanics tells us that particles can exist in multiple states simultaneously until observed. In one branch, you decided to read this. In another, you decided to sleep. And in yet another, a different quantum outcome unfolded in a distant galaxy. This interpretation implies an unimaginable number of parallel universes, constantly being created, each representing a different pathway of reality. It's a truly vast and overwhelming thought, where every choice, every random quantum fluctuation, gives birth to new, separate realities. For example, an electron might be in two places at once until measured. The many worlds interpretation suggests that at every quantum decision point, at every moment when a quantum wave function collapses into a single outcome, the universe doesn't just choose one path. Instead, it splits, creating a new parallel universe for every possible outcome. In some versions of string theory, our entire universe might exist on a brane, a higher dimensional membrane floating within a larger, higher dimensional space, often called the bulk. Imagine our universe as a sheet of paper, and other universes as other sheets of paper, all existing within the same larger room. These branes might occasionally collide, triggering new big bangs and creating new universes. Or they might simply float alongside each other, forever separate yet existing within the same overarching reality. Some might be too hot or too cold to form stars. Others might collapse almost immediately, and still others might be barren voids. But within this infinite landscape, there could be countless variations, making it statistically probable that at least one, perhaps many, would possess the precise conditions necessary for the emergence of life like our own. This perspective, while unsettling to some, elegantly addresses the fine-tuning problem. The observation that our universe's constants seem remarkably, almost miraculously, set just right for life to exist. The very definition implies a separation that current physics cannot bridge. Yet, the concept provides a powerful lens through which to consider the universe's origin, its constants, and the very nature of existence. It invites us to consider that perhaps our cosmos is not alone, but merely one thread in an infinitely complex, interwoven tapestry of realities. As you ponder the quiet expanse of the night, let this profound possibility gently settle in your thoughts. A limitless canvas stretching far beyond our own perceived reality. In this model, inflation, a period of extremely rapid expansion in the very early universe, doesn't just happen once. Instead, it is eternal, perpetually producing new bubble universes or pocket universes that pinch off from the larger, inflating background. Our own universe would simply be one such bubble, a region where inflation has ceased, allowing for the formation of stars and galaxies. It is a concept that moves beyond scientific observation into the realm of profound philosophical speculation. Yet it is rooted in some of the most advanced theories of physics. To contemplate the multiverse is to ponder whether the seemingly arbitrary values of our universe's fundamental constants, the strength of gravity, the mass of an electron, the speed of light, are truly unique, or if they are merely one set of possibilities. Others. One of the most compelling theoretical frameworks that gives rise to the multiverse concept is eternal inflation. Consider the implications of this. Each new bubble, in principle, could have slightly different physical laws or initial conditions. Another intriguing avenue leading to the multiverse is brain cosmology. Then there's the many worlds interpretation of quantum mechanics. This is perhaps the most philosophical and mind-bending version of the multiverse. Imagine an endless tree where every tiny quantum event represents a branching point. The multiverse hypothesis remains largely speculative. It is a theoretical construct, not yet directly observable. How would one detect another universe? The very definition implies a separation that current physics cannot bridge. Yet, the concept provides a powerful lens through which to consider the universe's origin, its constants, and the very nature of existence. It invites us to consider that perhaps our cosmos is not alone, but merely one thread in an infinitely complex, interwoven tapestry of realities. As you ponder the quiet expanse of the night, let this profound possibility gently settle in your thoughts. A limitless canvas stretching far beyond our own perceived reality. As we gently withdraw from the dizzying expanse of the multiverse, let us now focus our quiet contemplation on the ultimate fate of our own universe, exploring a concept that suggests not an endless expansion, but a grand, cyclical dance of cosmic rebirth, the Big Crunch. While the prevailing scientific view leans towards continuous expansion, the idea of a universe that eventually halts its outward rush reverses course from the initial burst of the Big Bang. It expanded outwards, cooling and forming the structures we observe. The galaxies, which are now receding from each other at an accelerating rate, would begin to decelerate. Then, with an unimaginable slowness, the cosmic flow would reverse. The cosmic microwave background radiation, a faint echo of the Big Bang's heat, would begin to warm, gently at first, then with increasing intensity. As the universe shrinks towards its ultimate collapse, temperatures and densities would rise to unimaginable levels. Galaxies would merge into supergalaxies, then into a single, vast, undifferentiated plasma. All matter would be crushed together, atoms losing their distinct identities. Much like our earlier contemplation of the singularity, but this time as a final, inescapable destination. One suggests a perpetual cosmic dance of destruction and renewal. A universe that is forever being born and reborn. Pondered the existence of countless other realities and mused upon the ultimate fate of all that is. These are the vast, enduring mysteries that continue to shape our understanding, gently reminding us of the profound depth and quiet beauty of the cosmos. Allow these thoughts to softly recede as the infinite expanse of the universe gives way to the tranquil comfort of your own space. Until our next quiet exploration into the annals of the sleepy scientist topic, may your dreams be peaceful and your rest profound. The other, a slow, quiet drift into an endless, solitary twilight. As you prepare to drift into the quiet embrace of sleep, consider these grand cosmic possibilities. Whether our universe is destined for a fiery recreation or a gradual, lonely fade. The contemplation of such profound scales and timeless processes offers a unique perspective on our fleeting. The immense gravitational forces would rip apart stars, then planets, and finally, even atoms themselves, reducing all complexity to a singular, scorching, incredibly dense point. This would be the Big Crunch singularity, a cosmic implosion. The once cool, expansive universe would start to compress, reversing the cooling trend that has defined its existence for eons. Stars, planet, and all existing structures would experience a gradual increase in ambient temperature, a slow warming as the universe itself became a more compact, more energetic environment. If dark energy continues to accelerate the universe's expansion indefinitely, then galaxies will continue to drift apart, eventually becoming so distant that their light will never reach each other. The universe would become an increasingly cold, dark, and empty void, with each galaxy an isolated island in an ever-expanding sea of nothingness. Stars would eventually burn out, black holes would evaporate, and all that would be left is a cold, dilute soup of fundamental particles, slowly drifting through an infinite, silent expanse. This is a vastly different end, a gradual fading rather than a dramatic regathering. The expansion would cease, and a gentle, inward movement would begin. Distant galaxies, once seen as receding, would start to approach one another, their light subtly shifting towards the blue end of the spectrum as they drew nearer. It suggests that the universe is not a singular event with a definitive beginning and end, but rather an eternal cycle of creation and destruction, expansion and contraction. Each big crunch might be a reset button, a cosmic reset where all information is compressed, perhaps to emerge anew in a subsequent Big Bang, slightly different, yet fundamentally the same. But what if this exhalation eventually loses its momentum? What if the collective gravitational pull of all the galaxies, all the dark matter, gravitational interactions, once leading to separation, would now pull cosmic structures closer together? Over truly immense timescales, galaxy clusters would merge. Then individual galaxies would collide more frequently, not with violent impact, but through a slow, gravitational embrace. The night sky, now predominantly dark with scattered pinpricks of light, would gradually become brighter, filled with the increasingly prominent glow of converging celestial bodies. And all the unseen forces within the cosmos eventually triumphs over the initial outward push and collapses back upon itself, offers a profound, almost poetic alternative to our cosmic story. Imagine, if you will, the universe as a vast, slowly exhaling breath. In the Big Crunch scenario, the expansion of the universe would first slow down, gradually, almost imperceptibly, over billions upon billions of years. This would be a period of immense cosmic reversal. The vast, empty spaces between galaxy clusters would slowly begin to fill. As the universe continued its inward journey, its density would steadily increase. The final stages of a big crunch would be a mirror image in reverse of the Big Bang, this cyclical model of the universe. A Big Bang followed by a big crunch, potentially leading to another Big Bang in an endless series of cosmic rebirths, offers a profound philosophical perspective. Contrast this cyclical social life of the universe with the current prevailing model of eternal expansion driven by dark energy. Both the Big Crunch and eternal expansion offer grand sweeping narratives for the universe's ultimate destiny. Our journey through the cosmic unknown concludes for tonight. We've peered into the heart of black holes, contemplated the universe's fiery birth, pondered the existence of countless other realities, and mused upon the ultimate fate of all that is. These are the vast, enduring mysteries that continue to shape our understanding, gently reminding us of the profound depth and quiet beauty of the cosmos. These are the vast, enduring mysteries that continue to shape our understanding, gently reminding us of the profound depth and quiet beauty of the cosmos. Allow these thoughts to softly recede, as the infinite expanse of the universe gives way to the tranquil comfort of your own space. Until our next quiet exploration into the annals of the sleepy scientist topic, may your dreams be peaceful and your rest profound.